Hello everyone, myself Professor Kishan GS, Assistant Professor, Department of Mechanical Engineering, Maharaj Institute of Technology. So myself and my co-faculty will be dealing with Module 4 in the subject 18ME34, that is Composite Materials. So here, as the name itself suggests composite materials, it is a study on different composition in building up or getting a material. Okay, so in this particular session, we are going to study three topics, that is definition, constituents and classification with respect to composite materials. Okay, so with respect to the definition of composite material, it goes like this. It is a combination of two or more constituent materials with different physical and chemical properties and which remain separate and distinct on a macroscopic level within the finished structure. See, as the name itself suggests composite materials, we can directly or simply justify the title as the combination of two or more materials. But when it comes to the actual definition of composite materials, wherein we are going to study its behavior or understand its versatility in application, we have to define the composite materials technically in the same pattern, wherein it has to give the information regarding chemical and physical properties as well as its nature under macroscopic level. So I repeat, it is the combination of two or more constituent materials with different physical and chemical properties and which remain separate and distinct on macroscopic level within the finished structure. Means to say that if we are concentrating on a composite material, it has to be a combination of two or more constituents, where the two or more constituents what it is being selected should possess different physical and chemical properties, because we are going to target the composition such that it gives better properties than the existing or conventional materials available for practical use. So we have to target the material with better combination that suits physical and chemical properties, all in all, to overcome the existent conventional material. And it should remain separate and distinct on macroscopic level. This is one of the uniqueness of composite material. If I can just quote a simple example, if you have come across the laminated plywood boards, you can see different layers of the material formation or material laid or piled up, so that gives the distinct or separate look of the different components available as per the composite material definition. So you can just take one simple example of that when you are viewing at the macroscopic level, because it is a finished structure. If you can just look at the plywood board here, so you will be having different layers piled up together or which are pressed together. So at the end or one of the end view, if you look at the object or the plywood board, you will get the different layers, and that is the macroscopic level of observation. Okay, so that is separate and distinct on macroscopic level. Say there is one particular comparison with an alloy here. In case of an alloy, in the microscopic structure you will get the distinct nature, whereas in case of composite material, it is the macroscopic level of study that leads to identification of separate and distinct phase of material which is considered in the composite combination. Okay, so this is something regarding composite material. Now let us go with the study on the constituents that forms the composite material. See here, when we are saying there is a combination of two or more materials, you cannot simply take the material which is available in the market and just go with the combination. There has to be the combination in two factors of consideration, that is the constituents. One phase is matrix phase, another phase is reinforcement phase. So the matrix phase is basically the binder phase and the reinforcement phase is the dispersed phase. So to go in detail with the understanding of these constituents, whatever the combination wherein we take for building up or developing a new composite material to overcome the existence of the conventional material for any application, the combination of material should be, one should be matrix phase and the other should be reinforcement, or at least to say like this, so two or more So if it is more than 2 in number, at least one should be matrix and that more number of material should be reinforcement. What is this binder and what is this dispersed phase? See, matrix phase is the phase of a material in composite material that binds together the material which are available in the dispersed phase. Means to say that the matrix phase is the phase that binds together the reinforcement that is accountable in the formation of composite material. We do have specific roles and responsibilities of matrix as well as reinforcement phase. Now we can just look at one after the other so that we get clarity among the reinforcement and the matrix phase. Keep in mind, so matrix phase is a phase that binds together the particles or the phase in which the material is dispersed, and that dispersed phase is nothing but reinforcement. Okay. Now we'll go with the understanding of matrix phase. What is the roles of matrix phase? What is actually a matrix phase? See, matrix phase is a material phase wherein it holds the reinforcement material. As I have said, it binds the material. Okay, so the binding material is matrix and the material which is getting binded in matrix phase is called as reinforcement. So now it holds the reinforcement material. This is one of the major role of a matrix phase in composite material. Next comes keep them aligned. So whatever the way in which you need the reinforcement to be aligned along a particular direction, so matrix phase will keep that particular reinforced material in the same aligned position throughout its life. Okay. Next comes the third important point. It protects the reinforcement from mechanical and environmental effects. See, basically when we concentrate on reinforcement and matrix phase, reinforcement is the phase which takes the maximum load which is being applied on the material, and reinforcement phase is the phase that takes or gives the strength and stiffness to the material. So since to get maximum strength out of the material composition, this matrix phase protect the reinforcement phase by being affected by mechanical or environmental. Mechanical, say for example the additional loading conditions or any type of load conditions that leads to the extraction of strength from the material. Whereas in case of environmental effect, it may be due to the presence of moisture or any other atmospheric content on the material. Next comes the last point of the matrix phase, which is a very important point that provides shape and form for the composite material. Whatever may be the reinforcement material, so to what extent or to what shape the composite material is to be developed or to be built, so matrix phase is the phase that leads to that particular shape and form of the composite material. You take any of the shape of it may be a container, it may be a laminated sheet, it may be a flat platform, it may be any inclined with some spines as such. So whatever may be the design or whatever may be the shape, matrix phase is the phase that leads to the formation of that particular shape as required in the form of composite material. Next comes the reinforcement phase. As I have already said, reinforcement phase is the phase that is going to be binded by the matrix phase to form a composite material. So basically to say, reinforcement is the dispersed phase that actually be considered in the composite material. One of the major roles of the reinforcement phase is that it carries load, provides strength and stiffness, as I have explained while taking up the point 3 in matrix phase. So reinforcement phase is the phase that actually results in carrying the load which is being applied on the material. So whatever may be the type of load, it may be tensile load, it may be impact load, it may be any kind of load which is being applied on the composite specimen, it is the reinforcement phase that takes the load and results in the strength and stiffness of the material. Next comes obtain desired properties in preferred direction. See, we have the matrix phase to keep the reinforcement in the aligned direction. So whatever the direction wherein the reinforcement is to be kept, so in the same direction, okay, we will be keeping the reinforcement binded together using matrix phase. But in order to get any kind of desired properties along the particular direction, it is the orientation or the alignment of reinforcement phase that results in the desired properties along the preferred direction. Say for example, if the reinforcement is horizontal, no, it is from left to the right or horizontal from the view here. So if I just start pulling a tensile loading condition based on the direction of reinforcement phase, since it is horizontal for the viewers now, along the horizontal direction, if there is a pull or a tensile load condition, you will get the desired properties only because of the aligned reinforcement in the horizontal condition or horizontal direction. So this is one of the major point of reinforcement phase. Next comes the last one. It serves as heat resistance, corrosion resistance, and provide rigidity to the composite material. So whatever the way wherein the composites are preferred, okay, it has to be heat resistance or it has to be corrosion resistant, as well as it should possess high rigidity, and these are the parameters which are accounted only due to the presence of reinforcement. So basically what happens when we go with the development of composite material, we do have the choice of considering the proportionality limit of the presence of reinforcement phase as well as the matrix phase. It can be 50% of reinforcement, 50% of the matrix, or if you want better strength properties, if you have better curing techniques wherein we are going to study during the production of composites in this module, okay, at that particular point of time what we do is that we keep maximum of reinforcement and we keep optimum content, necessary content of matrix to bind the reinforcement. Say for example 50, 50 is one phase, 55, 45, 60, 40, 65, 35 as such. So the combination will be worked out based on the targeted applications which is being considered for the requirement of composite material. Next comes the last part of this particular session, that is classification of composite material. So here the classification goes based on the constituents as well. So the first type of classification of composite is based on the matrix material, and the second type of composition is based on reinforcement material. In matrix phase we have 3 categories, and in reinforcement phase as well we have 3 categories. Totally we have 6 types of composite materials classified at a rate of 3 each on 2 types. First one being metal matrix composite. In this particular classification, if the material of matrix is made out of metal, okay, which binds together the reinforcement phase, and that type of composite is called as metal matrix composite. As the name itself suggests, it is the matrix material which is made out of metal. Next comes ceramic matrix composite, CMC. Here the matrix material is made out of ceramic materials, and hence it is called as ceramic matrix composites. And finally, the matrix phase is polymer or the resin or organic polymer, then you are going to consider the classification as polymer matrix composite. So here all the 3 types of classification under matrix phase is based on the type of matrix which is considered to bind the reinforcement. Next comes the type of classification based on reinforcement. In reinforcement we have 3 categories. One is fiber reinforced, another one is particulate reinforced, and the last one is laminate composites. So if it is to be considered as fiber reinforced composites, then the reinforcement type should have the fibrous nature in its condition. Means to say that it should have a long threaded like structure. The length of the thread depends on type of applications or type of composition wherein we prefer. But the reinforcement should be a long threaded like structure that forms fibrous in its nature, called as fiber reinforced composites. Next comes particulated composites or particulate reinforced composites. Here the reinforced material should be in the form of fine powders, flakes, chips as such. It should be a particle identified nature of reinforcement, and then we are going to consider it as particulated reinforced composites. The last one being laminated composites. Here the reinforcement material should be available in the form of layers, so that one above the other a layered material can be held and pressed together to form a layered composite. Okay, so this is the nature of reinforcement. Fiber means a long threaded like structure. Particulate means maybe powders or chips or fine flakes like conditions of material phase, whereas in case of laminate the reinforcement should be in the form of layers or a sheet of paper like kind. So this is about the classification of composite materials. Now let us understand the details of different types of composite materials based on its classification. First, let us concentrate on the classification of composite materials based on the matrix phase. The first one being metal matrix composites. As I have already said, the matrix phase is what is being considered here in case of the metal matrix composite. But we cannot stick on to only matrix phase. We have to also understand what is the type of reinforcement and what are the preferred reinforcement materials that could be selected, okay, when we opt for metal matrix composite. We'll go like this, to understand the metal matrix composite, the generally preferred metal matrix materials are aluminum, titanium, magnesium, iron, cobalt, copper, etc. So these are the materials which are generally preferred as metal matrix materials when we concentrate on metal matrix composites. So here, once we have these materials as the metal matrix materials, then what are the reinforcement? So the preferred reinforcement for metal matrix composite should be of fibrous in nature or fiber reinforced composite material, or the small particles of ceramics, means to say that it could be the fiber reinforced or particulate composite materials could be the combination once we develop the metal matrix composites here. Okay, so here the nature of the reinforcement should be fibrous in nature or small particle type, but the preferred materials are ceramics and metallic materials only. Here you cannot think of any other polymer material to go with the metal matrix composite. You have to select the reinforcement phase such that it is one among the ceramic or metallic material like lead, tungsten, or in case of ceramics like oxides, etc. Okay, so this is about metal matrix composites, the matrix phase as well as reinforcement phase. Now comes the advantages, limitations and applications when we opt for metal matrix composites. Okay, being the advantages side, it possesses high specific strength, high operating temperature, low coefficient of thermal expansion. Okay, so these are the advantages that could be accounted when we take metal matrix composite. So it is directly saying that, okay, along the strength, along the temperature, along the thermal parameter, okay, metal matrix composites do have advantages. Okay, followed by the disadvantages, it do possess high density, low ductility and high fabrication cost. So since we are targeting the metallic materials in both reinforcement and matrix phase here, when we opt for metal matrix composite, then definitely the fabrication cost becomes high as well as the density increases, and thereby due to the combination of such, there is a low ductility parameter identified here in metal matrix composite that becomes one of the disadvantage. Moving on with the applications of metal matrix composites. So it gets identified in various applications in automobile sector, marine applications as well as the turbine blade applications as such. So to quote few of the applications, it is identified in piston, push rods, brake parts which are preferred in automobile sector, and turbine fan blades, okay, etc. as the applications when we take metal matrix composite. Means to say that the materials or the composite material which is built based on the metal matrix phase do have its identification in automobile sector, okay, turbine fan blades as such. Now let us concentrate on the second type of composite material based on the matrix phase, that is ceramic matrix composites. So here the preferred ceramic matrix is silicon carbide, aluminum oxide, zirconium oxide. So these are the preferred ceramic matrix phases of the material when we opt for ceramic matrix composites. So what is the type of reinforcement then? Okay, the probable composition works out when the reinforcements are fibrous in its nature, means to say that fiber reinforced composite. Okay, then preferred material in fibrous form for reinforcement is silicon carbide, aluminum oxide or mullite. So since both reinforcement and matrix are of same ceramic material composition here, this category of composite material, that is ceramic matrix composites, are also called as ceramic reinforced ceramic matrix composites. Okay, so ceramic fiber reinforced ceramic matrix composites as such. Okay, so then again, when it comes to the advantages, disadvantages and limitations here, so it do have high melting point, one of the major advantage, because melting point play a very vital role when we go with the opting of material in its extreme conditions or extreme temperature conditions in its application. So high melting point is one of the major advantage for ceramic matrix composite. Good corrosion and oxidation resistance. That is to overcome the existing disadvantage in case of conventional materials, wherein they are going with the corrosion as well as they do react with the oxidation parameter here in case of conventional materials. But if we opt for composite materials made out of ceramic matrix, then it do possess good corrosion and oxidation resistance. So that is the major advantages for the ceramic matrix composites. But we do have certain disadvantages like high brittleness and crack resistance forms the disadvantages of the ceramic matrix material. Followed by the application, it do have its applications in various areas like automobile sector, space applications, using in gas turbines as such. In case of automobiles or in case of airplanes, okay, basically due to its less wear, okay, we do prefer this type of materials in airplane applications like disc brakes in airplanes as well as the racing cars. And we do have its application in space applications, wherein we do opt for its usage in developing the nose material in the space and leading edges in the spacecraft. Okay, moving on with the gas turbines, they are considered its use in the combustion liners, in sealing devices as well as bearing units in the gas turbine. So this is the few of the listed applications for ceramic matrix composite. So it is basically due to the less wear parameter that is opted here in case of ceramic. Moving on with the third type, it is polymer matrix composite. So here the preferred matrix or the organic polymer or resins, what we generally say, it will be of two types. One is thermoset, another one is thermoplastic. So thermoset and thermoplastic are the two categories of the matrix phase which are preferred in polymer matrix composite. Okay, so here when it comes to thermoset, we have different materials, and when it comes to thermoplastic, we do have different materials. When we consider a thermoset based polymer matrix composite, the preferred matrix materials are polyester, unsaturated polyester to be very specific, epoxy resin, vinyl ester resin as such. So these are the materials which are selected as the binding elements or the matrix phase in the polymer composite when we opt for thermoset type of matrix. Whereas in case of thermoplastic, we have polycarbonate, polyvinyl chloride, nylon, polystyrene as such. So these are the thermoplastic category of matrix phases when we opt for polymer matrix composite. And the reinforcement type, whatever may be, irrespective of thermoset or thermoplastic, okay, the reinforcement are generally preferred in fibrous form. That is, fiber reinforced composites are preferred when the matrix phase is polymer. And basically the preferred reinforcement materials in the fibrous form are glass, carbon, graphite, boron, aramides, etc. So means to say that these are the materials, that is carbon fiber, glass fiber, graphite fiber, boron, aramides to say it is Kevlar, so which are basically considered in bulletproof jackets manufacturing. Okay, so those are the the fibrous materials which are considered or preferred reinforcements when we opt for polymer matrix composition, and it has its own advantages over other type of composite materials as well as the conventional materials. So once the list of advantages includes the lightweight, abrasion and chemical resistant, high strength and stiffness along reinforcement direction. This is the point of focus now. So whatever may be the direction of the reinforcement based on its alignment. So before now we have studied when we concentrated on the reinforcement phase, it is on the direction of fiber, it gives better strength and stiffness. Similar is being identified here, high strength and stiffness along reinforcement direction. If the load of application is along the direction of reinforcement, and since we have the fibrous form of reinforcement which are preferred here, and we generally say it like along the direction of fiber, if the load is being applied, then the polymer matrix composite gives high strength and high stiffness to the composition, and it has also corrosion and fatigue resistance. So since we don't have any influence of metallic materials here, okay, we do have the composite materials to be corrosion resistant in maximum cases. Okay, so that is one of the advantages for the polymer matrix composites. And moving on to the disadvantage, the polymer matrix composite do give low impact and low tensile strength parameters. Okay, and when it comes to its application, the applications are widespread. It is found in aerospace, marine, sporting goods and domestic appliances. Wherever we have the materials which are not conventional metals or metallic in nature, then we generally prefer the polymer matrix material to be its application or to be its alternative in the existence. Okay, when it comes to aerospace, you can think of the seating elements, the sealing devices as such. When it comes to marine application, the polymer matrix composites do have the formation of the entire structure of the boat or ships. And when it comes to sporting goods, you take the rackets, you take the golf bats, you take any kind of bicycle frames. Nowadays, it is all made up of the matrix, the polymer matrix composite. And domestic appliances like a few of the cutleries, handheld devices, bathing units as such are such examples which could be taken out of polymer matrix composites. So this is the first phase or first categorization of the composite materials based on matrix phase. Now let us take the second category of classification of composite material based on the reinforcement. As we know, we have three types. We will take one at a time. The first one being fiber reinforced composites. So as the name itself suggests, fiber, so in this type of composite materials, okay, the nature of reinforcement should be elongated thread-like structure, or in the form of, say, a thread or the fiber. So here length of the fiber depends on type of applications wherein we are targeting or the type of strength we are targeting at the end. Okay, so but whatever may be the type or the length of the fiber here, but the nature of fiber should be, or the reinforcement should be, elongated thread-like content here. So the reinforcement elongated thread-like structures are preferably from metals, ceramics, glass, polymers as such. So when we say the fiber reinforced composite, the elongated threaded like structures are basically made out of metals, ceramics, glass and polymer. So this is to be your notice to understand regarding fiber reinforced composites. But here, along with the definition or the type of reinforcement of elongated threaded like structure, we do have different types of arrangement and types of the fiber. Okay, we have three categories here. One is continuous and aligned. You can just observe in the drawing, it is continuous. There is no breakage in the length, overall length of the threaded like structure, and it is in line with the alignment. Okay, hence it is continuous aligned type. Next comes the discontinuous aligned. Here the arrangement is along vertical platform, that is, it is aligned in its condition or the arrangement, but the length of the threaded like structure or the fiber is not as that of the first type. Hence it is aligned, but it is discontinuous. So the length of the fiber are not same in this particular type. Then the third type being the discontinuous randomly arranged. Here there is no alignment and there is no maintenance of the length of the threaded like structure. Hence this category is considered as random and discontinuous type of fibers. So this is about the fiber reinforced composite. Next comes the concept of particulate composites as it is been defined. So the reinforcement type, that is particulate composite, consists of the reinforcement in the form of particles, which are generally flakes, powders or chopped fibers. So if you take the fibrous composite or fiber reinforcement here, the threaded like, elongated threaded like structure, if it is cut into pieces of a very small size, even that can be considered as particulate in the particulate composite. So basically the reinforcement type will be flakes or chips in nature, small chips, powdered. Okay, powdered may be completely amorphous or may be a very minimum crystalline in its nature, as well as the chopped fibers. So these are the different types of reinforcement types or the materials phases which could be considered under particulate composite. So here whatever the powder, whatever the particles which are considered in the form of reinforcement here, that should always be preferred with less than 0.25 microns in the binding phase. Means to say that the reinforcement materials which may be flakes or powders or chopped fibers in case of particulate composites, that are to be embedded in the matrix phase such that the particulate size is less than 0.25 microns. So you can observe here, so if this is a shape of a composite specimen, the small particles represents the particulate phase in the overall matrix phase of the composite. So this is about particulate composites. And the last one, which has its huge amount of application in the present trend, that is laminated composites. That is, the reinforcements are nothing but a cloth-like structure or a layered phase of the material. Okay, so preferred materials in the reinforcement are made out of glass, graphite, silicon carbide, boron, etc. But here these are the materials preferred which are to be of a layered structure or a cloth-like structure in its presence, so that it can be piled up one above the other as per the requirement. Okay, so but in case of laminated composites, okay, there is a preference given for the different types of selection of matrix here. Okay, you cannot simply take whatever the matrix which are available, but there is a preference given for the selection of matrix only for laminated composites, and those matrices are nothing but epoxies, alumina, titanium, aluminum, polyamides, etc. Okay, so though these are the matrix phases which could be categorized under different types of matrix phase of composites, but for a laminated composites, okay, these are the only preferred matrix phase. So you can observe the condition here. So this is an entire structure of composite specimen. We have 5 layers arranged one above the other that forms the laminated composite. So this is basics of different types of composite materials. Now let us move on to the last topic of this particular session, that is advantages, limitations as well as the applications of composite material. So in this particular entire session we have started the content regarding the definition of composite material, constituents of composite material, okay, the roles and responsibilities of matrix phase as well as the reinforcement phase, the detailed classification of composite material based on the matrix type as well as based on the reinforcement type. So now comes one more additional content, that is advantages of composite material. So the advantages of composite material goes with the non-corrosive and chemical resistant parameter. Since we have limited amount of presence of metallic materials in case of composite materials over the targeted application, okay, the composition will always be non-corrosive and chemical resistant. So this is one of the major advantage which accounts for the utilization of composite materials in very strange areas of application. Next comes high strength to weight ratio. So here that itself defines that the capacity of composite material is such that for a very less weight it provides very huge amount of strength in its behavior. So that is high strength to weight ratio. Lesser the weight, higher the strength is the capacity of composite material. Next comes durable and dimensionally stable. So the curing of composite material will be made such that its dimension is retained even after subjecting the material for its application. So durability is one of the major issue because it gives very standard properties like non-corrosiveness, chemical resistance, okay, so less wear and tear, and it also targets the application like the environmental degradation parameter is very less in case of the composite materials. Hence it leads to the major parameter called as durable. Next comes low thermal conductivity. So thermal conductivity is the capacity or a property of a material to conduct heat or to conduct heat energy. So here what happens, since it has low thermal conductivity, it is an added advantage for the composite material because it doesn't conduct heat. Okay. Next comes low coefficient of thermal expansion. Coefficient of thermal expansion is a property or a parameter that describes the size of the object that changes with respect to changes in the temperature. Okay, so size of the object that changes with respect to changes in the temperature is what we meant by coefficient of thermal expansion. If that coefficient of thermal expansion is low, means to say that whatever may be the changes in the temperature, the shape or size of the object tries to retain same is the benefit for composite material. Hence it is low coefficient of thermal expansion. Next, low electrical conductivity. Again, electrical conductivity is the capacity or a parameter in which the material do have the ability to conduct electricity. Okay, so here it is low. Next comes very good fire retardants, that is it is flame resistant property of a material, okay, that leads to the advantage. The last parameter of today's consideration on the advantages is directional tailoring capabilities. Means to say that based on the direction of application of load over a material, whether it is longitudinal or whether it is transverse direction, so you can just build or develop the material, okay, or it can be tailored to meet that particular targeted application or type of application of load. So here what happens, directional tailoring capabilities means whatever the direction in which load is going to be subjected on the specimen, on that particular direction itself to give better strength, you can develop the material. Okay, if it is to be a tensile loading condition along horizontal direction, or it is tensile loading condition along transverse direction, or if it is compression along the same pattern, whatever may be the type of loading condition, so you can develop or tailor the material so that the type of load along the direction is assisted based by the composite specimen. Next comes the disadvantages of composite material. So since we have the combination of two or more materials here, wherein the composite materials are being considered for the development or preparation, okay, to meet any targeted application, so the main factor that comes into picture is the fabrication cost. So majorly the disadvantages in case of composite material is the cost factor. Okay, wherever the cost factor comes into picture, that leads to be one among the major disadvantage for composite specimen or composite material. The first one being fabrication cost. Since we are targeting two or more materials at two different phases, matrix and reinforcement phase, okay, fabrication of the blending of reinforcement in the matrix phase becomes a huge investment at the start. Hence fabrication cost becomes very high and it becomes one of the major disadvantage for composite material. Next comes the raw material cost. See, since we are targeting again the combination of reinforcement and matrix, selection of material becomes a major role here. So it has to have the compatibility between the reinforcement and the matrix phase. So when we do select these reinforcement and matrix phase, there is always a chance of increase in the cost because the raw materials of the materials which are being selected leads to huge investment. And next becomes the third one of the, again, the major important disadvantage. It becomes more brittle than the wrought metals and hence can be easily damaged. So brittleness is one of the major drawback of composite material that leads to, breakage or initiation of break in the specimen. Next, reuse and disposable may be difficult. Since the composite material consists of two or more materials, it is not that easy to recycle the material to get another product, or it is not easy to dispose the product into the environment because there will be combination or the characterization of two materials that leads to different inheritance properties on the environmental factor. Hence reusability and disposal is difficult in case of composite material. And the last one being transverse properties may be weak. Say for example, if the fibers are arranged in the horizontal direction and if the load being applied is transferred, that is perpendicular to the direction of fiber, then this is one of the major threat in the composite material, wherein the property of the material, if the loading condition is transverse, that is if it is perpendicular to the direction of fiber, that gives very weak results in the testing condition. Hence it becomes one of the major disadvantage of composite specimen. Now comes the key area, that is application of composite materials. So let us go with the highlighting factor or the areas in which the application of composites is identified. Then we shall have the look upon, okay, the images that leads to the understanding of where and all in different areas the application of composite materials is being identified. Okay, so we have aircraft industry, spacecraft, automobiles, construction field, sports equipment, biomedical industry, marine industry and military applications. So these are the major areas wherein the composite materials have been considered in its application. Now let us look upon the direct images that leads to its utilization in different areas as described here.